EUPEX stands for European Pilot for Exascale. It's a 4-year project starting on January 1st, funded at 50% by the European, the Euro HPC-GU, and also by the participating states, which are France, Germany, Italy, Greece, UK, or not UK, because ECMWF is an international organization, so it's not UK in fact, Czech Republic and Croatia, for a total budget of 40 million euros. So it's, you can see here all the participants in EUPEX project. So it's a balanced consortium of 17 European academic and industrial stakeholders, with some established European technology providers and some of the most renowned research and HPC centers in Europe.
Excuse me, Etienne, we are stick, at least on my side, on slide 2. Is it same for others?
Yes, sorry, here is it.
Yeah, thank you.
And with some partner bringing their real-life application in the project. Maybe before going further, I would like to do a step back and indicate the purpose. Why are we tackling this project together with API project, European Processor Initiative, and the EU pilot? We are working on the, I would say, the European deep technologies, working on making it possible to procure in Europe the chips and other technologies that are needed to make EU computers, computers used in Europe. If we look at the microprocessor side, for instance, Europe is only providing 10% of the processors globally used in Europe, which is far below the usage. I think Europe is probably using something like 20 or 30% of processors produced in the world, but only producing 10% of them, and almost none in the HPC domain. So here we have certainly a specific niche which can provide a unique opportunity to enrich EU's capacity to control his supply chain, and also to bring back more value in the supply we have in Europe. So it's really a sovereignty matter. To be prepared for the future, we need to have a level of mastering of these technologies, and also to be able to do ourselves our own choice, globally speaking, in Europe. So we can see here a EUPEX project as a part of a long story, which started more than 10 years ago. For instance, we have here the footprints of Mont Blanc project, Deep Sea project. We have also API's outcomes with the general purpose processors and accelerators brought by API to be integrated in EUPEX pilot project. And we can see here EUPEX as having a key position, in the EU network of know-how. EUPEX having the role to gather some key EU technologies from API, but not only for API, having the role also to interact with key user communities such as COEs, with the other pilot, EU pilot that will be presented later by Carlos, and enabling the use of this technology in future EU exascale systems. This is really the purpose of EUPEX. So just a brief reminder of the key concept developed within API project. we work on two main technical streams. On the left side, the general purpose processor, and here the choice done are to use the ARM ISA, and so it's the generation of REA chips to be provided by Cyper. And on the right side, we have the accelerators that will provide the computing force that is needed in today's systems more and more. And there we are working on RISC-V chips, and we are realizing some EUPEX test chips within the project. Of course, we need also to work on optimizing the interworking of those two kind of chips. And so that's a specific item. This may be done at several levels, at a die level or not. So we have several standards that can be used, and that's a topic of work for sure. So here about our objective, the target is to, as said, to push our EU technology at a pilot level, and to check the readiness and the pertinence of this technology. So this may be done at several levels. So we have here to co-design, and we are undertaking a co-design for a modular exascale pilot system. We will have to build and deploy this pilot hardware, also demonstrate, as said, the readiness of the technologies embedded there, and work with application to adapt when it is needed the application to have a full benefit of the technologies, and also to take into account the application need in our choices. So the key concepts embedded are, for sure, as already said, to include a high level of EU technologies, and we'll have more indication in next slide. Work on energy efficiency with a power stack implementation, leverage on an open architecture with Bull OpenSequana form factor blades, also target multi-tier data infrastructure, and a pre-production maturity level. So the European building blocks that have been selected for the hardware integration are the REA processor proposed by Cyper, also leverage on the modular supercomputing architecture to efficiently connect and orchestrate the heterogeneous resources. As already said, the Bull OpenSequana architecture with Bull Sequana X compute cabinet, BXC as an interconnect, Parastation Modulo from Bartek as a management suite, Ocean also to administrate the whole stack, and some tools that will be seen a bit later. So to have a closer look to the system, as said, the requirement is to have something modular with, and therefore we did choose to have an OpenSequana compliant hardware platform, matching also the modular supercomputing architecture standard, and also second point, to have a large enough system to be a good proof of concept, and to search to have a production grade system, for instance, with liquid cooling, etc., to really check the industrial readiness of the solution. So if we now want a closer look on the choices, we'll have some Sequana blades dotted with only with general purpose processors, and we'll have up to 32 blades dotted with accelerator. So the choice has not been done now, but you can guess in the list of usual suspects what may be the choice done. We also have, as an additional goal, the intent to integrate the RISC-V test chip produced by API project in a beta system, which will be air-cooled. So, of course, it's simpler for integration, but this will be an additional side aspect. So looking now on the software stack, this is a work in progress. So all the choices are not done, but we are working on the 4 levels indicated here on the data access stack to implement the multi-tier storage architecture. Also on performance and energy efficiency tools, on the execution environment, and on the management software. So we, of course, we push the solutions that can be supported by our participants, but not only, and we are looking also to some open source solutions. To check the adequacy of our choices, we have selected the 6 specific domain of interest. We have here climatology and weather, combustion, biology and health, astrophysics, seismology, and remote sensing analysis. And we are working on implementing some real application from these domains on our platform. And so it will be what we can call a real test bench. And to have a closer look to the weather use case with IFS, we, of course, I will not present IFS. It's well known in weather community for sure, and used for medium range forecast with high resolution model, also for medium and extended range ensemble, and the seasonable ensemble forecast. So that's really one key application in the domain. And in EUPEX, we plan to work on optimizing progressively for API, for instance, with SV vectorization, with the use of HBM. Also, port GPU-enabled component to our hardware, and demonstrate an execution of the full prediction workflow on the prototype. So it's not only having a mini app, it's really having something representing, not at scale, but a good representation of the whole application. And here, the actors working on this application in the consortium are ECMWF, and Olivier Marsden, for instance, is representing ECMWF in the project. So now to conclude, I may say that pilot stage is key to bring technologies to the market and to the industrial level. And we are often not so good in Europe to pass this pilot stage. So it's really key to be successful at this level, to ensure the future of the technology we want to promote in Europe. Second point, we are really looking forward collaborating with COEs, in particular with the EasyWays COE, because we think it is important to, of course, to have the adequate technology choice on the pilot, and to prepare to test together the readiness of the technologies, and to prepare the future, to prepare the applications. To conclude, it's really a long but a rich road towards the EU-powered exascale systems.